There is a spherical object whose mass is 100 gram that can be written as 0.1 kg. Now this mass is dropped from a height h, which is equal to 10 meters. Let's consider this is the height, 10 meters. It is dropped, which means the initial velocity is 0. As the ball goes due to acceleration due to gravity, this will get some acceleration. Sorry, this will get acceleration as well as velocity. So just before hitting the ground, it will have some velocity. Let's consider that is vi. With velocity vi, it is hitting the ground. Now, uh, also we can say with momentum pa, it is hitting the ground because the mass we know, and if we know the speed, we can say momentum also. Now, after hitting, it will rise up with some velocity. Let's consider that is vf. Okay, so after hitting the ground, it is rising up and it is going to height 5 meters. So that's what given in the question, and we need to find the momentum, rate of change of momentum, that is impulse imparted by the ground. So we need to find the impulse. Impulse can be written as change of momentum. It's not rate of change, but change in momentum is known as impulse. So change in momentum means final momentum minus initial momentum. Here we need to find the momentum. So there are multiple ways to find the momentum. We can use the equation of motion, find the velocity and multiply it with mass so that we can find the momentum, or we can use conservation of energy also. So I'll try to use conservation of energy and solve this one. So let's consider the first case where the ball is dropped from the top and it is like going down and it is going to hit the ground. Okay, so from here it is dropped and this is the ground. So here it will have some energy and here also it will have some energy, and these two energies should be same. This initial energy should be equal to final energy. Initially it will have only potential energy, that is mgh. Finally it will have only kinetic energy. While hitting the ground it will have only kinetic energy, which is half m v squared. Okay, so I want to convert this into momentum. So mgh can be written as p squared by 2m. Okay, so now I want to write p. So p will become 2m squared gh. Yeah, square root. This can be written as m into root of 2gh. So the momentum we can write in this way. Initial momentum we can write in this way. Similarly, I want to write final momentum. Final momentum is the one, the momentum just after hitting the ground. So just before hitting the ground is initial momentum. Just after hitting the ground is final momentum. So how to calculate this? For that, you have to consider this as initial position and the ball or the object has raised up to 5 meters. Okay, so you consider this as final. So initially it will have only kinetic energy, and final position it will have only the potential energy. Here also we can do the same thing. Maybe this is h dash. So mg h dash will be equal to half m bf squared, or I can write it as pf squared by 2m, which is mg h dash. Now we can write a pf. Pf will become m into root of 2g h dash. So we have initial momentum, we have final momentum. Now we can find the impulse change in momentum, pf minus pa. You see, this is a vector quantity, so we have to take care of the direction also. So when momentum is in this direction, let's consider it as positive. When momentum is downward, we'll consider it as negative. So final momentum direction, it is upward, so positive should be m root of 2g h dash. Okay, minus initial momentum is downward, so it should be negative. Negative m root of 2gh. So we'll take the terms which are common. We'll rewrite this properly. Yeah, m root of 2g is common. Then we will get here root of h dash plus root of h. So we can substitute all the values. M is 0.1, root of 2 into 9.8. This is root 5 plus root 10. If you simplify all these things, you will get around 2.39. Unit is kg meter per second. So this is the impulse the object is going to give. So the most important part of this question is how do you consider the initial and final momentum to find the impulse? So initial momentum should be the momentum of the object just before hitting the ground. Final momentum is just after hitting the ground. If you take care of that, then remaining things are simple.